Okay. Hello, everyone. Hello, everyone. Welcome back to Calculus 1000. Today, we will there's a last piece from the continuity that I have to cover. This is about the famous theorem, intermediate value theorem. We will go through it. We will do some examples. And then on the second part of the today's class, I will start working on limit at infinity, a topic which is not from the chapter 2. We are taking it from chapter 4, but it's only a piece that we will continue before we go into the derivatives. Before I start, is there any questions, any comments? Okay, then let me go ahead and write down what is intermediate value theorem. This is one of good applications or something that holds for continuous functions. We will go to details, but basically what it says is if I am here now at North London and at 5 p.m. one of you see me in somewhere South London, say in Costco, South Costco, and then at 5 p.m., then you can say for sure that at some point between 1:30 to 5, I crossed Oxford Street. So I have to, if I don't jump, if I don't fly, if I am driving or walking, there is a point that I will cross Oxford Street as the horizontal street that goes all the way from both sides. This, now we want to write it for the functions. The assumption, let f be a continuous function on an interval AB. What does that mean? I'll get back to it in a second. We already know what is being continuous on at a point, but this is about an interval, and there is a small tricky point that we have to look carefully into that. Okay? Now, if I want to fix any value between f at a and f at b. So the values of the function at a and b, you fix any value between these two. So either k is between f at a, f at b, or it could be the other way around. It could be that f at a is bigger than f at a and k is between them. But I would say the clearest way to say this is that k is any value between a and f at a and f at b. So f is continuous. K is between the values of the function at two endpoints. Then there exists a point C in the open interval AB. There is a point which is between A and B such that f at C is equal to that number k. So any value between the two end values of the function will be achieved by our function. Or if I want to show this on a graph, say this is point A, this is point B. Say f at B is here, f at A is B here. Now, anything in between, fix k between these two things. So in other words, you can fix any line y equal to horizontal line y equal to k. And by the intuitive definition of what is continuity, you see that there is no way that I can go from f at A to f at B without crossing y equal to k. So no matter how hard I work, my graph at some point, maybe not here, goes up, maybe at the end, there is a point at which this function, the graph of this function, crosses y equal to k. And this is about an existence of such thing. I know I have to do some examples just to show you what is the importance of that. But I will write one remark about the continuity on an interval, and then we do the example, okay? So remark, f is continuous on the interval AB. What does this mean? Okay, well, it seems it's clear, yes? At any given point, it is continuous. But there is a small problem with this statement. Can anyone say, what is the problem if I just go say that, oh, f is continuous at all the points from A to B, including A and B? Any? Does that worry you when I say that it is continuous on the open, closed interval A at A to B? Not at all. Okay. There is one thing that you have to be careful about. Well, if x is between if x is a number, but the two ends of that interval, there is no problem. F must be continuous, it's continuous. But at the end points, there is a problem at the end points. Remember, the continuity condition says that limit of f of x as x approaches to A must be equal to f at A. But how do you know that your function is defined on the left-hand side of this point A? Maybe you cannot even approach to A from both sides. I can approach to A from the right-hand side, but there's no guarantee that I can approach to A from the left-hand side. So when it comes to the end points, what I mean by continuity at the end points is one-sided continuity. So as x approaches to A from the positive side, from the inside of the interval, this is equal to f at A. Limit of f of x as x approaches to B from the left, there's a negative there, is equal to f at B. Or I can say this is right continuity at A, this guy left continuity at B. That's the most thing I can say, because there is no guarantee that my function is defined even outside that interval. But whenever I ask you to check the continuity on an interval, I mean in the between these end points, it must be continuous. But at the left end point, you only check the limit from this side is equal to the value. For the right end point, you check from the left side, the limit is equal to that. Or in other words, I want to make sure that my function goes all the way, sticks to f at A from the right hand side, sticks to f at B from the left hand side. Any question before I write the example down? Okay. So I think we have the observation clear there. Now, I'll write down the example. We will work on this. Example, show that function cosine squared x minus x has at least one root on the interval 0 to pi over 4. The function is cosine squared of x minus x. Before starting working on this example, I will give you 30 seconds. This is not, I'm not asking you to apply IVT. Consider yourself stuck in an island and you don't know what is IVT. I want you to see the difficulty of proving something like that without IVT so that you can appreciate what IVT can do. Okay? So you're in an island with a friend. You have 30 seconds to think about why this question makes sense and why is it hard or difficult to come up with a mathematically meaningful answer for that. Go ahead, please. Is everything okay?
You're just supposed to say.
10 seconds, and I will need one volunteer to tell us what you thought about that. Okay. Okay. I need at least one person to say what you think. Why this question makes sense, or why is it difficult, or why this kind of gives us the right intention to go and figure out a problem or a theorem like IVT. Any? Even if it is a small, don't worry. You don't need to answer that completely. Yeah. Any small piece of information for me? Did you talk about that one with your friend, or you were talking about your Facebook posting? Do you guys even use Facebook these days? Oh my God. Am I that old now? What is it? What is the social media these days that you... Instagram. Okay, I know that. I'm not that old. Okay. I just made a small mistake. Okay. So the first thing you should see here, we are trying to find, or we are trying to basically solve this equation. Having a root means at some point it is 0. And what I want you to see is that this is not one of those equations that you can solve. It's not quadratic so that you just plug it into the formula and find it. It's not even one of those simple trigonometric equations. This is highly non-trivial, strange equation. So there's no way you can go ahead and explicitly try to solve it. Okay? But you can do something about the graphs. See, if cosine squared minus x is equal to 0, you can actually look for this equality, yes? Where cosine squared is equal to x. And then try to see if you can, in some ways, sketch these two functions and see if they intersect at some point or not. Well, cosine squared has a funny something like something along these lines, a graph like that, okay? And then y equal to x is somewhere here. Oh, look, I can see, using the graphs, I can see there is a point they intersect. Believe me. Yes, actually, it is kind of mathematical argument to say that there is a point that these two intersect at. But is this point less than pi over 4 or bigger than pi over 4? My question is asking a bit more. It says that make sure or show me that not only it exists, but also that point of intersection happens before pi over 4, yes? So things are kind of complicated and there's no straightforward thing. That's how you kind of start thinking of, oh, this guy is not just for fun there. It does something interesting for me, okay? Are we all good on that, or no, you can believe that you can do it without IVT? Well, that's a good challenge for you maybe to keep it this afternoon to think about it, and give me if you can do it without using IVT. Okay, now, I am aiming at using IVT, and there is one important thing. Calculus is mostly about how to write things, yes? I can guarantee the first IVT will come out, more than 70% of you will lose mark on how you wrote solution for IVT-related problem. More than 70%. And I can guarantee that 90% or more of you actually knew that what is the solution, but your writing caused you loss of mark. So here is one of the things that you have to carefully follow what implies what. I have 3 things to prove when I want to use IVT. One, I have to make sure I write down few sentences or few words why my function is continuous. So here, I will say f of x, which is cosine squared of x minus x, is continuous on the whole real line. On the whole real line. Okay, how? How is it continuous? Because cosine x is continuous. Apply power law if cosine squared is continuous. Apply subtraction or difference law, cosine squared minus x is continuous. And everything is on the whole real line. Wait a minute, my IVT is asking me to show that it is continuous only on the interval AB. You're telling me it is continuous on the whole real line. How is this discrepancy are not going to kill my argument? Anyone can give an answer for that? Why what I'm writing down there will be good enough for me to apply IVT? Yes, please.
It's continuous on all, but it's going to be continuous there.
What I'm giving you there basically is even more than what IVT needs, yes? But I would still encourage you to write this thing. Then f is continuous on that whatever interval is. We want to get as close as to the assumptions of the IVT theorem. Okay, that's first thing I have to do. Second, now I'm done with the continuity condition, so I said few things just to to support my claim that it is continuous. Now, what is k in this case? What is k here? K is what? Roots. Okay, but what does root mean? What does root fixes for us? Huh? You change your mind. Someone. Yes, please.
Intercept between 0 and pi.
0. So in this case, k is equal to 0. We want to find something which is the function at that point is equal to 0. So k for us in this case is that. Now I have to show that f at 0, this end of this interval, is either bigger than 0 or less than 0. So let's evaluate that. Cosine squared at 0 minus 0. Cosine 0 is, oh, louder. I need that louder. Cosine 0 is 1. Square it. 1. 1 minus 0, so I get 1. What I showed there is that, OK, f at 0 is going to be bigger than my k. Now, I should be able to show that f at, should I write it down there? No, I don't have enough space there. I'll write it over here. Now, f at other end point, I should show that is, that one is bigger than k. Now I show that it's less than k. OK? So this is cosine squared of pi over 4 minus pi over. What is cosine of pi over 4? Root 2 over 2. Square that, 2 over 4, or half. Someone is breaking the promise they made before. Didn't you tell us on the first week that I'm not going to ask you to evaluate strange numbers? How are you expecting me to evaluate half minus pi over 4? What would be the answer for that? We are changing the place. Why don't you need calculator? In other words, why don't you still need the calculator? Pardon? You're OK putting like that, but I need that number for something. Can you use that to get that something? Yeah, go, don't worry. Yes?
So minus pi over 4.
Oh, OK, I see. You're trying to simplify a little bit, which is a nice simplification. But why do I need that number? Like, what should I show for that number? F at pi over 4, what should I show? Yes?
Less or greater than k.
Less or greater than k is just 0. Yes? Here, in this case, we already showed that this is bigger than 0. So the only thing I need, OK, that's a number. What I need is this negative number or positive number? Yes? Negative. Why? Because I know approximately this is 3.14. 2 minus that. That is negative number. Again, the value of the number is not important. The being positive or negative is what we are looking for. So what we showed here is that, OK, so let me write it over here. F at pi over 4 is less than k. So I go sit in my car. I put the key in, turn the key. The car is on. I put the gear at the gear, yes? And then I push the gas pedal. What will happen? What will happen? Is that's not obvious? Come on, guys. So I turn on the car, put in the gear, push the pedal, gas pedal. What will happen? It will move. It will move. Now my car is IVT. Turn on the car, put in the gear, push the gas pedal. It will move. It will move and give me the result that I'm looking for. I can put a sound effect there. I can go now. Yes? But what does moving for IBT means? IBT says, you do these 3 things for me, I will do this part for you. So then IBT will tell me that there exists a C between 0 and pi over 4 such that if at C, or cosine squared at C minus C is equal to K. Check the assumptions of your theorem, and then once you have all of them checked, the theorem will start doing the job it is supposed to do. In this case, it will tell you that there exists, and this C is the root we are looking for. Doesn't make sense. You should focus on 2 things. What IBT says, or the second thing, how I'm supposed to write down the things when I'm using IBT. And the second thing is more important, I think, at this point, because you guys have seen IBT probably a million times. And now we focus on write things carefully so that mathematically it makes sense. Any questions, any comments? One of the questions that I hear at this point is that, oh, are you going to ask us to find what is that C, value of that C? No. The question, the way it is set, it says that show only existence. Existence means that there exists something there. Are you looking for finding that value? IBT says, I'm sorry, I cannot do that. Go find other tools for it. But IBT guarantees such root exists. That's one thing. And we won't, if questions like this happens, you won't be asked to evaluate that value. Through an example, show that continuity is required or is a necessary condition or assumption for IVT. If you can buy something cheaper, why you should pay more? In other words, if you can get the same results with less assumption, why you should have more assumptions there? One of the assumptions is continuity. Now the question for you is that find an example that shows continuity is required. In other words, all the other things could be right, but continuity, and then the result of IVT won't hold. I'll give you 45 seconds to think about this problem and come up with an example. Well, even if you can make sense of that, what is the question asking? That's enough for me. But please go ahead, 45 seconds, and you have to work with your friend on this one. You're trying to come up with an example, a function, an interval, and a k, which has all the condition given on IVT, but continuity, and it doesn't satisfy the result of continuity. Go ahead, please, 45 seconds, and I'll walk around. If I see some of you don't talk to your friend, I'll make you to talk to your friend. That worked. Five seconds. Okay. I need one example. Who wants to share their example? Yes, please. Oh, I see. That's a good example. That's a good example. So I can start at A. I can put a hole there. And then at B, I can go like, OK. And then, sorry, maybe I can do this and then here. Yes? Let's do more. This is 1. This is 5. Yes? And the function is this thing. Now, let's say this value is 4, and this value is 2. Yes? Now, if you don't have the continuity, even in one of the endpoints, that's a good example in that regard. Even in one of the endpoints, the continuity is not there, then look. If k is equal to 3, no value on the interval, x interval 1 to 5, gives me k for the function. They don't intersect. Yes. Other examples could be any. For example, you can go 1 over x when x is not 0. When x is 0, you put 1, and then take interval to be -1, 1. Yes? And take k value equal to 0. So you can check those conditions. If at -1 is negative, if at 1 is positive, and 0 is between -1 and 1, and then there is nothing that achieves 0 for me there. So continuity and all the other conditions, all the other conditions are more clear, they are necessary. But continuity is very important. You have to make sure that you check it carefully. Any questions? Any comments? Let me write another example in a little bit different nature, but they're all the same things. Show that 4 to the power, the equation 4 to the power x is equal to 5 minus 3x has a solution. It has a solution. One minute? Would 1 minute be enough? Yeah? There are specifically two things about this example, but I'm hoping that while you're trying to set up your problem with your friend or you're alone, you will notice those two things, and I will ask you that as the first thing when we try to solve it on the board. Go ahead, please, 1 minute, and yes, talk to your friend. Yeah, don't let that freezing look in your face stay there. Talk to your friend about this. Go ahead, please. Okay. So to be able to apply IVT here, there are two things that are different than what we have before. Can anyone point out what was the challenges, maybe, challenges about this problem to set up, to be able to use the IVT? Yes, please. There is no interval. There is no clear interval given here. That means that part of the problem is asking you to figure out the right intervals. That's one thing. Thank you. What else? What else? What's the function here?
Polynomial with exponential function.
Which part? Is this the function I'm applying IVT on, or is this the function I'm applying on?
You bring everything to one side and then
You should bring all one side and leave the other side constant. Leave the other side constant or 0. For example, I could go ahead and say that, okay, f of x is this guy, and k is 5. I can bring it all but a constant to the right-hand side. Or I can say that, oh, no, I'm going to do minus 5 here, and k is 0. One side must be constant. It could be 0. Yeah? OK. Well, let's check the conditions. 1, f is continuous, yes? Why? It is difference of exponential and polynomial functions, which both are continuous. They are continuous, so I don't know what to write. XP and poly are continuous on R. So the function is continuous on the whole real line. So it is continuous on the whole real line. Well, I will find some interval, but that will come later on. But if it is continuous on the whole real line, it will be continuous on the interval. Now, to find an interval, what should I do? What should I do? Yeah, I can graph. But one endpoint of interval is always easy. You just pick any number. It's going to be either positive or negative. Either way, it is going to be useful. Pick any number you like. If, say at -1, are you OK with -1? Yeah? OK, I plug in here. This is 4 to the power -1 plus 3 times -1 minus 5. Well, this is 1 over 4. This is -8. -8 plus 0.25. It's a positive number. Sorry, it's a yeah, sure. It's negative number. -8 plus 1 over 4. It is a negative. No, I don't need to know what is the exact value, but I can see it is negative. One point is easy. The other point, now, I found an endpoint at which the function is less than 0. I have to find another point at which the function is bigger than 0. What should I do? Well, just try some more points, and hopefully you can figure out the right thing. For example, if I plug in 0 here, this is going to be 1, 0, -5. 1 minus 5, is that a good endpoint? No, it is giving me another negative. How about let's plug in 1 here. 4 plus 3 minus 5, it is Positive, it's 2, yes? So then that's the other good endpoint. I have a function which is continuous on the whole R, in particular on -1 and 1. Yes? I'm just fixing it as the interval so that it works nicely. Yes, please.
The first one you didn't write the answer, but for the second one you wrote, you have to like write the answer or just like specify if it's bigger or smaller than 0.
We have to make sure we are showing these assumptions here, yes? So if at -1 was bigger than 0, or sorry, maybe it was less than 0, sorry, it was this case. Now the other one, I have to find something at which the function gets a positive value. So yeah, I will try different things, but once I found that thing, I would like to show that, oh, I see what I was looking for. I know what is going on in your brain is good, perfect, but this is not about what is going on in your brain. This is what's going on in your writing. So you have to show me that you cared about this other condition as much as you cared about this one. Does that answer your question? Or maybe your question was completely different thing. Oh my God, I said so many things. There, yeah, go ahead.
So as long as we just specify if it's less or bigger than 0 for each one, that's enough.
That is good, but you should keep in mind, you should have both bigger than 0 and less than 0. Yes, then that's good, yes. Okay, so should I go with my sound effect again? Yeah? First assumption, second assumption, third assumption. 1, turn on the car, put it in the gear, push the gas pedal, and then it goes on. It tells you what you were looking for. There exists a number C in the open interval -1 to 1 such that f at C is f at C is 0, is equal to K. Okay? Or in other words, I know that there is a number 4 to the power C plus 3 times C minus 5 is equal to 0. Or in other words, C is a solution for 4 to the power C minus 3C or 5 minus 3C there. Are we all doing good there? Yeah?
Quick question.
Sure.
Is it necessary to have like those last 2 lines at the bottom?
This is just me trying to get more things down there, yes? It never hurts if you write few more things to just affirm or confirm what you have been saying, yes? Yes, please. Yes, yes. Louder, please.
Where the C is in like -1 to 1. Or
Oh, I see. That's a good question. So let me go back. Let me go back to our IVT. See, when I'm checking continuity, I have to check closed interval, yes? But I'm saying that f at A is less than K, but not K, yes? And f at B is bigger than K, but not K. So no matter what I find between A and B, that A and B cannot be the endpoints, because I already said they are not going to be equal to K. That's why writing C from the open interval is actually giving you more information than writing closed interval. Yes? So if this is not equality, you can write this as open interval, which has more information to give away. Any other questions? Yes, please. Oh, I can move that, yes. Okay, I think I don't have enough time to start the new topic. Tomorrow you come back, we are working on limit at infinity. And it will be one session, we should finish it in one session. Have a great day and see you all tomorrow.